In this question, you have two objects that have the same size and shape, but one is heavier and they are dropped from rest. So let's assume ball A and ball B, they are of the same size and shape and both are released from rest. So comparing, you want to check whether the heavier objects in terms of terminal velocity and acceleration, which one is higher, which one is the same. So, first of all, since the mass of A is greater than the mass of B, in other words, your weight of A is greater than the weight of B. So, because W equals to mg, so that means to say the weight of your A will be much greater than the weight of B. So let's start with the initial acceleration. Now, because when you first release the ball, there's no air resistance, so it's considered free fall, and you know that free fall, the value for acceleration due to free fall is 10 meter per second square. In other words, when you drop the ball, the only force acting is its weight. So the net force, which is your ma, equals to your mg. Therefore, your acceleration basically has a magnitude of 10 meter per second square downwards. So both will have the same initial acceleration, 10 meter per second square. So that means to say for the velocity time graph for both A and B, the initial steepness of the graph will be the same. All right, the gradient is 10 meter per second square. Now, next about terminal velocity, we have to consider a very important point. Your air resistance, in a way, is directly proportional to your speed. Now, of course, sometimes you know that your air resistance is directly proportional v square, sometimes it's v. Now, in general, this is for low speed, this is for higher speed. But for our O level, we just need to know as the speed increases, air resistance will increase. That is more important for us. All right. So having said that, let's consider a very small speed for both. They have the same speed, so the air resistance will be present. And you can see that for that small speed with that air resistance, very highly likely for B, the air resistance will be equals to the weight. And when that happens, it will continue to fall at constant speed, which we call it the terminal velocity. In other words, the graph here for ball B, very soon it will reach terminal velocity because the net force is equals to 0, the acceleration will be 0, so you will just continue to fall at that maximum constant speed, terminal velocity. But for the same speed for the air resistance, for ball A, you can see that there's still a net force downwards, so it will continue to accelerate. The speed will keep on increasing, then obviously the air resistance will keep on increasing until a point at a higher speed where the air resistance is equals to the weight. So that will take a longer time, and the constant speed or the terminal velocity will be higher because it has more time and higher speed to reach that air resistance to be equals to the weight. So if I were to draw the graph for the VT graph for the object A, initially the gradient is the same 10, then after that you continue to accelerate until a longer time and a higher speed before it reaches terminal velocity. So the terminal velocity of your A will be higher than the terminal velocity of B. So the answer will be C. The heavier object will have a same initial acceleration but has a higher terminal velocity. All right, thank you.